everyone. My name is Spencer McIntyre. I'm really happy to be here. I hope everyone's having a great GitHub universe so far. So we're here to talk about the Metasploit Framework, and if you're not familiar with it, we're going to go over a little bit about what it is, show a little bit about how it can be used, and finally close out with talking about how to go ahead and contribute to it. So like was mentioned, my name is Spencer McIntyre. I am the research lead on the Metasploit project at Rapid7. I've been a Metasploit contributor for about 10 years now. I've been contributing content to the Metasploit framework. Started about 10 years ago. So it's been a great and wild ride, and I'm here to share a little bit about that with it. So Metasploit is an open source security framework. It started out as an exploit framework, which is like the core of the content, and it has since evolved into that to be a framework to facilitate security research and most notably security testing, which is what we're going to be talking about quite a bit. And when I say security testing, we're thinking about like penetration testing. We're looking for, authorized users that are looking to emulate malicious users to try to identify security flaws and vulnerabilities and prove that they can be leveraged in order to achieve something potentially dangerous or malicious. So that might be, crashing a system, most oftentimes stealing data and things along those lines. And so they do that by leveraging the exploit content, and that's all part of the open source project that we provide. And so this is a slide with a whole bunch of the users, just some of the many users that have contributed to the Metasploit framework since its time on GitHub, which has been on GitHub for quite a few years now and is now the core of our workflow, where we accept contributions through pull requests, like many other projects out there. So like I mentioned, we're going to talk a little bit about what Metasploit is today. I've already talked about how it's intended to help users emulate malicious users and to play the part of the bad guy and kind of show the possibility of like what could happen. And the intention of like why we would want to do this is in order to be able to go ahead and help people identify flaws so that they can fix them before actual malicious users get around to doing it. And so that whole workflow is going to be part of the penetration testing workflow, which we're going to talk a little bit about the overview of what that workflow sort of looks like, so that way we can better understand how Metasploit fits in and the various steps as part of that workflow that Metasploit really helps out and to facilitate. And then we're going to talk about contributing to Metasploit and my favorite type of content, which is going to be, of course, the exploit content. So with that, Metasploit is a collection of operational capabilities in terms of exploit modules that are going to leverage a vulnerability to achieve some kind of an effect that is most oftentimes not going to be the intended effect. It's going to be exploiting a vulnerability to achieve, say, code execution, information disclosure, privilege escalation, something along those lines. So who might want to use this? Well, Metasploit is a sort of toolbox that provides libraries for exploitation tasks. If you're watching this talk, you're probably a developer and you're probably very familiar with the concept of libraries. Well, writing exploits presents some interesting problems, and like many other coding problems, it makes a lot of sense to have reusable code in the form of libraries in order to be able to go ahead and facilitate that. And that's one of the things that Metasploit provides, is a sort of baseline functionality with a lot of the libraries so that exploit developers and vulnerability researchers can get off the ground running very quickly and sort of prove the exploitability of the vulnerability that they're looking at. And that kind of leads right into the second set of common users, which are going to be like the penetration testers, the people that are looking for these vulnerabilities that have content in Metasploit, so that way they can go ahead and identify and prove that they exist. And when we say prove that they exist, we're trying to ensure that there are no false positives, because if you're familiar with security, you've probably run vulnerability scans. You can know that false positives can be an issue. They can be a problem that lead to wasting time. You're not entirely sure if the vulnerability exists or something along those lines. And that's kind of where Metasploit can really help out, where when it has an exploit module, the exploit module can be leveraged to deliver another kind of module, which is going to be like a payload. And this is one of the nice parts of the frameworks, that you can select this other type of module, the payload, to be what you want to happen when the exploit occurs. So that way you can show definitively that no, this vulnerability that we may have thought was a false positive is a real thing. It can be leveraged, and we should prioritize fixing it accordingly based off of the findings of what we had. We leaked critical information. We should patch this today, or there wasn't really anything, so maybe we can push it till next month, something along those lines. And so I've already mentioned a couple of the module types that are going through Metasploit, which is like the core of the framework is built out in these content blocks that are the modules. So we have the exploit modules, which are everyone's favorite modules. Is the one that we have the most of. And the exploit modules are used to go ahead and deliver payload modules, which is, like I had mentioned, the type of content of what occurs if an exploit is able to leverage a vulnerability to do something malicious. That something malicious is the payload module. And so when working through those are two of our modules. We also have encoder modules, which handle things like bad characters in the payload, which is a very common problem. If you're an exploit developer, you have applications that, if it's a stack-based buffer overflow, maybe you have bad null characters, because that's the terminator for a string. So you need to encode your payload in order to get around that. So we have encoder modules for that. We also have post modules that can interact with established sessions from payload modules that can do interesting things after an exploit has taken place. So once we have compromised a system, we want to be able to show the potential impact of it. And that's where the post modules would come in and kind of help us take a look at, what could be done. And in order to go ahead and help out with this whole process, we have a couple of evasion modules trying to be sneaky and test detection capabilities. And then finally, the last and second most popular type of module is the auxiliary module. And that's kind of catches everything that doesn't fall into one of those other categories and is very important for reconnaissance, scanning, enumeration, which is kind of how Metasploit helps put everything together. So in terms of the workflow, we might start out with using an auxiliary module to go ahead and look for a vulnerability that we know is high profile. Metasploit has an exploit module for it, something along those lines. So we'll fire up an auxiliary module and check a class C of hosts, so 254 hosts, and check to see, does this vulnerability exist? Does the service present? And then from there, we'll identify that it is, and we'll move on to an exploit module, choose a payload that we'd like to be delivered, and go ahead and exploit the service. Upon successful exploitation, we'll have a session, and then that's when the post modules come in. The post modules can use that session to, for example, enumerate out sensitive information that might be stored in the browser, leak clear text credentials out of memory, something along those lines. It's going to be looking for that sensitive information, so that way the tester, whoever is operating Metasploit, can go back to the owner of the system and show the stakeholders, look, we were able to find, this information using this vulnerability. So this one should be addressed with a much greater sense of urgency than, say, some others that we perhaps, weren't able to exploit. Maybe it's false positive, something along those lines. That way we're able to help users triage and prioritize those vulnerabilities, because we all know our time is not infinite. We have a certain amount of time, so we want to be able to use it most effectively. And Metasploit can help us get that knowledge in order to go ahead and do that. So breaking down the workflow a little bit more, I've already kind of mentioned starting out with reconnaissance and scanning. These are where the auxiliary modules are heavy hitters out of Metasploit. We're looking for targets, we're identifying services that we might be interested in, say SMB, RDP, and of course our favorite HTTP. We want to be able to identify, is the server Nginx, or there popular web applications on it, like say maybe WordPress, something along those lines. We want to be able to identify our targets. This is very often if you don't know, or you're not looking for a very specific target. If you're looking at for example, a whole network worth of hosts, you're going to be spending a lot of time in the scan and the recon phases. From there, once you have your targets, moving on into the attack phase, where you load up an exploitation module and try to go ahead and leverage the service, and then hopefully you're successful and you've compromised that system. Now, this is how it's often taught in a very linear fashion, but I can tell you from experience, it doesn't quite work out like this in the real world. A lot of times you bounce around between the different steps. You might go from reconnaissance, and for whatever reason, you identify a service that you're very confident is vulnerable, and so you move on into the attack phase. And, perhaps the attack doesn't work, so you move back into the reconnaissance phase, and you're looking for another system, and so on and so forth. So it doesn't quite work out this linearly or this cleanly in the real world, but it's all good because Metasploit kind of helps to facilitate all of that. And so the sort of glue that Metasploit provides to combine all of these things, I've already mentioned there's a lot of those modules. Metasploit helps take those modules that would otherwise be isolated tools that users might perhaps run and turn them into a sort of workflow. So in terms of the scanning and the reconnaissance phase that I've already mentioned, when we utilize our auxiliary modules to go ahead and look for a service, the Metasploit database in the background is going to be gathering information that's reported by these modules, including what systems are online, what services are identified, and then key pieces of information that are important from an exploitation perspective, such as what vulnerabilities might have been identified, what versions of software are affected. So if we find an old version of WordPress, it's going to be noted in the database, and we can sort of feed that module, or excuse me, that information into the next step of our workflow, where we might be looking for attacks that can leverage that old version of WordPress or something along those lines. So the database is sort of the core of the glue that ties this workflow together. And so with that, I'd like to show a quick demo of how this might look. In this particular example, we're going to go ahead and we're going to show using an auxiliary module to go ahead and identify systems that are vulnerable to a high-profile vulnerability, MS-1710, that came out quite a while ago. You'd be surprised, we do still find systems with this vulnerability present occasionally. But it's very easy to exploit. So as a tester, if I'm looking at a network, I would definitely want to identify this vulnerability. It might be one of the very early steps that I'm using while I'm doing my scanning and my reconnaissance. So I'm going to use Metasploit to go ahead and run this module. And it's going to go ahead and it's going to identify a system that's vulnerable. And it's going to store that information for me in the database. So it's kind of like keeping those notes for me automatically. Of course, as a pen tester, I'm probably going to be keeping a notebook and keeping those separately. But if we ever forget, we lose that, we have this information in the database, which is what we're looking at here. So we're seeing the systems that were identified and the services and the vulnerabilities that were noted. So right now, it's a very small example. If we were looking at, say, like 1,000, 2,000, 5,000 systems, this would become very, very important, very valuable, as it's filling all this information out for us. And what we're doing is we're going to go ahead and take this knowledge that we had, and we're going to move into the next phase, where we're actually going to go ahead and exploit this vulnerability. So we load up the exploit module and we set the information that we had just gathered. We go ahead and we run the check method to make sure that the vulnerability is going to work before selecting a payload and then ultimately exploiting the vulnerability, which is what we can see here. As it's holding on for just a couple of seconds, this exploit usually takes just a few seconds to run before it is successful. And you can see that the prompt changed into the Meterpreter prompt. So we're in kind of a different workspace at this point, where we're interacting with an agent that was provided by the payload that we selected, that we utilized to compromise this system. And of course, in this particular example, leveraging this vulnerability, we were able to obtain full administrative access on this system and have fully compromised it. So we'd move on to, say, the exfiltration phase, where we'd be looking around at the file system on this system, trying to identify anything interesting that we might want to take out to use as proof of what an attacker could do, and if they had leveraged this vulnerability. So that's sort of the demonstration there. So then with those steps afterwards, we might wanted to have looked at, say, the lateral movement and post-exploitation. So we kind of saw, when utilizing Meterpreter, we moved right on into the file system, but we could also automate that with a lot of the post modules. I can go ahead and look for that. Finally, once we had wrapped up and done what we needed to do, we'd go ahead and we'd clean up after ourselves and take part in what's the most important part of the assessment, and that's the reporting. And that's, again, where the database that stored all of that information is really going to help us out as an assessor, so that way we can get the important facts and relay that to the hosts that are responsible for the systems that we were testing, so that way they can address the findings that were there. So a quick note on cleanup: a lot of the stuff that Metasploit does is memory resident, so rebooting is going to fix it. We don't write too much out to disk unless, of course, the user specifies a module to do that. So we try to keep things in memory as much as we possibly can. So with that, we've talked about the content in Metasploit, which are going to be those modules. And so those are the contributions that we get quite frequently. One of the most popular contribution types that we get is documentation. The vulnerability that we looked at is a very, very high-profile vulnerability. It's very common, but we have a lot of ones that are quite a bit lesser known. And so there's been a big push over the past couple of years to document a lot more of the content in Metasploit in the form of module-specific documentation to help the user understand, what the vulnerability is, what the module does, how it can be leveraged, and those types of things. So it's a very common contribution that we get that's very, very valuable. It helps people understand and digest the content that Metasploit provides, which can oftentimes be very dense and, by the very nature of it, very, very technical. The most common contribution type that we get, though, is new module content. So we're going to talk a little bit about that from the perspective of exploits specifically, which is our most popular module content type. These often come from one of two resources. Either it's brand new research that the vulnerability researcher who identified the vulnerability might go directly into Metasploit and create the module directly in Metasploit, leveraging the capabilities and the payloads and the encoders and everything that are provided by Metasploit. So they'll make the module and they'll go ahead and release it as part of the vulnerability disclosure to show, to demonstrate the vulnerability, to prove that it exists, that type of thing. A second common is we get a lot of ports of public exploits. So for one reason or another, a researcher may not write it for Metasploit. It may be a little bit difficult to write for Metasploit for whatever reason. Perhaps they're not as familiar with the framework. But there's a lot of public exploits out there. They're not all for Metasploit, and so we have a pretty large community of folks that will identify public exploits and then port them over into Metasploit, which is very nice because then we have our exploit content in a standardized format in a framework. So that once you have the framework installed, you can go ahead and, from a security practitioner's perspective, utilize this content. So what are some of the benefits of using a module for Metasploit? We kind of talk about, people either directly write it for Metasploit or they don't. Of course, I'm biased as one of the top contributors. I'm a huge Metasploit fan. I bet you wouldn't have guessed that. But there's a lot of benefits to writing content for Metasploit. One of the great things is that when you're writing an exploit, a lot of times you don't really need to worry about the payload. It's not necessarily relevant to the module or the vulnerability that you're trying to leverage. So Metasploit provides that for you, and you don't have to worry about it. Another capability is that database that I've been talking about, is all of the reporting capabilities. If you write a one-off tool, you're probably ending up, putting output to the console and expecting the user to go ahead and take their notes manually, which isn't the best user experience. But if you're doing it in Metasploit, you can log, version information, service information, credentials that you have gathered, and things like that. Finally is transparent proxy support. So when you compromise a host, you can actually leverage that and have vulnerabilities be leverageable through that in terms of being able to pivot, which is a very powerful capability for users that are looking to expand into networks. They're able to compromise the system and leverage that to then attack other ones. So if you see a lot of value in those and you want to contribute a Metasploit exploit module, the exploit modules themselves are broken down into kind of three main components, which we'll go ahead and take a look at. The first of which is going to be the metadata and the particular options that are provided to the user, so they can go ahead and check those out. The next is the check method. Not all exploits have this capability, but we try to provide check methods for all the exploits that we can. It's very specific to the vulnerability, but the idea is to provide a safe way to be able to see if we think an exploit is going to work without actually exploiting the system, which can unfortunately be inherently dangerous sometimes. There's a chance that you may crash the service, and that may be undesirable. Of course, we understand that, so we provide check methods that are intended to be very, very safe. And then, of course, the core of the logic is going to go ahead and to the exploit method, which is actually going to leverage the vulnerability to go ahead and do the thing and deliver a payload and demonstrate the vulnerability itself. So this is a quick example of the module metadata. It's basically just definitions. There's no real logic in here. We're showing, references. I was the author of this particular module. We have our target definitions down there. This also includes metadata that we can go ahead and relay to the user in terms of what might happen when this module runs. If it does go wrong and things, fail, is the system going to restart? Like the underlying operating system, is that going to restart? Is it just going to be the service that restarts? Is it highly unlikely that the service will be adversely affected? All of these vulnerabilities are unique, and so we want to be able to relay this information to the user so that way they can make an educated decision based on the information that we've provided to them on whether or not it's an appropriate action to go ahead and exploit this module and go ahead and attempt it. So we just want to make sure that they have the tools available to them to make an informed decision about what's best for their environment. And that leads right into our check method. If you don't want to take the risk of going ahead and running the actual exploit, a lot of our newer modules have check methods, which are going to go ahead and provide a little bit of logic to make a best effort guess to see, are we confident we're going to be able to exploit this? Does it appear to be patched? Can we even determine that the service is running? Something along those lines. So in this particular example, the underlying vulnerability was that a cryptographic secret was leaked. So we're able to go ahead and gather enough information to see if we can sign something with a publicly known secret and identify if the vulnerability is present or not. And there's no code execution, nothing is corrupted. So this is a very safe technique to check this particular vulnerability. But again, it's very, very context sensitive. And lastly, we go ahead and be the actual exploit module, which would expand on this particular content quite a bit by actually implementing the logic in order to go ahead and leverage the vulnerability to demonstrate that it is in fact present. And with that, I want to go ahead and thank you for your time. I hope you found the Metasploit project as interesting as I do, and maybe perhaps you'll be interested in checking us out on GitHub.